All right, let's talk about a type of math problem that, let's be honest, trips up a lot of us. Average problems. But what if I told you there's a secret to making them, well, kind of simple? Today, we're going to pull back the curtain on that secret. Let's get right into it.
So what if I told you that every single one of those tricky questions you see, the ones about teachers' salaries, student test scores, daily temperatures, what if they were all just the same exact problem wearing a different disguise? Well, they are. And once you see the trick, trust me, you can't unsee it.
See, here's the trap we all fall into. We see the word average, and we get fixated on it. But it's a distraction. It's not the main character. The real hero of the story, the key that unlocks every single one of these puzzles, is something else entirely. It's the total. That's where all the action is.
Okay, so let's get right to it. Let's reveal this hidden secret. It all boils down to one simple, powerful tool. This is the thing you're going to use every single time.
And here it is. This is your secret weapon. This is the master key. From now on, whenever you see an average problem, I want you to completely ignore the average at first. Instead, the very first thing you're going to do is find the total sum. And you do that by just multiplying the average by the number of items. That's it. This one little shift in focus, it changes everything.
All right, let's put this secret weapon to the test. We'll start with what I like to call the game of ins and outs. These are the problems where people join a group or maybe they leave and everything gets jumbled up. Our job is to figure out exactly what changed.
Okay, here we go. A classic example. We've got 17 teachers and then 3 of them leave. The average salary changes. Now, your brain is probably screaming, do something with the averages, right? But nope, stop right there. Don't fall for it. Remember our secret weapon.
So the best way to tackle this is to think in terms of before and after. We have what the situation looked like before and what it looks like now. And what's our first step? Always. We find the total sum. We don't care about the average salary right now. We care about the total pot of money, the total salary pool, and how it changes.
Okay, let's crunch the numbers. Step 1, find the original total. That's 17 teachers times 45,000, which gives us $765,000. That was the before total. Now, step 2, the after total. That's 14 teachers times 42,500, which is $595,000. So the total salary pool shrank, right? Well, that money had to go somewhere. The difference between those two totals, that is the salary of the 3 teachers who left. It has to be.
And just like that, you have your answer, $170,000. See? No confusing algebra, no getting tangled up in averages. We just focused on the total, and the answer practically fell into our lap. It really is that simple.
And you know what's cool? This works no matter what. It doesn't matter if people are leaving a group, like our teachers did, or if someone's joining a group, like a student, getting a new test score. The logic is exactly the same. The secret is always, always, always to track how the total sum changes. That's where you'll find the answer.
All right, ready to level up? Now we're going to look at problems where you're juggling multiple groups. A couple of small groups that make up one big group. These can look way more intimidating, but I promise you our master key, our focus on the total, it works just as perfectly here. So here's the setup. We have 22 candidates in total. We know their overall average score. And we also know the average for the first 10 candidates and the average for the last 11. But what about that poor 11th candidate who's not in either of those subgroups? What's their score? You know the drill by now. Forget the averages, let's find the totals.
This is just a simple puzzle, really. The total score for all 22 students combined has to be the same as adding up the scores of all the parts, right? So let's find those totals. The grand total for all 22 candidates is 990. Okay, the total for the first 10 is 550, and the total for the last 11 is 440. So we have the total for the whole group, and we have the totals for the 2 main chunks. The score of that missing 11th candidate is just, well, it's the missing piece of the puzzle.
And would you believe it? The answer is 0. A big fat 0. It's the only possible answer. Because 550 from the first group plus 440 from the second group plus 0 equals the grand total of 990. It's kind of funny, right? A weird answer that becomes totally obvious once you look at the totals. Okay, time for the final boss battle. This next problem is a little more abstract, a little more tricky. It deals with overlapping groups, and it's designed to make you feel like you're missing some crucial information. But just watch how our focus on the total strategy just cuts right through the confusion. Check this out. We have the average temp for Tuesday, Wednesday, Thursday. Then we have the average for Wednesday, Thursday, Friday. Notice what's happening.
Wednesday and Thursday are in both groups. They're the common ground. The only things that are different between these two groups are Tuesday and Friday. That's the key to the whole thing. So, let's find the totals.
Let's walk through this. The total temperature for that first block, Tuesday, Wednesday, Thursday, is 111 degrees. The total for the second block, Wednesday, Thursday, Friday, is 114 degrees. Now, think about it. Since Wednesday and Thursday's temperatures are the same in both calculations, that 3-degree difference between 111 and 114, where can it possibly come from? It has to be the difference between Friday's temperature and Tuesday's temperature.
And this is the last piece of the puzzle. We just figured out that Friday is exactly 3 degrees warmer than Tuesday. The problem helpfully tells us that Friday was 39 degrees. So the math is super simple now. 39 degrees minus whatever Tuesday's temperature was equals that 3-degree difference.
And that means Tuesday had to be 36 degrees Celsius. And there you have it. We just took down the trickiest problem yet, and once again, who was the hero that made it all make sense? The total sum.
So, think about what we just did. We looked at 3 totally different kinds of average problems: people leaving, subgroups, overlapping dates, and the same exact strategy worked every time. This isn't just a trick for one type of question, it's the master key.
So let's lock this in. Here's your new strategy, your game plan. Step 1, see the word average and immediately ignore it. Step 2, always find the total sum first. Step 3, focus on how that total sum changes. Is it going up, down, or what's missing? Step 4, use that change to find your missing piece. And finally, always remember, the total is the hero of the story, every single time.
And that's it. The next time an average problem comes your way, you won't even break a sweat. You'll know the secret. Which leaves us with a bigger question, right? Now that you have this master key, what other things in life that seem really complex are actually pretty simple if you just learn to look at them in a different way? Thanks for tuning in.